All welcome everyone to the online course on Essential of Database Management System. In previous video lecture, we discussed tuple relational calculus. In this presentation, we are going to discuss domain relational calculus. The domain relational calculus, simply we call as DRC. It is a non-procedural query language in DBMS based on first order logic. DRC uses domain variable that represents the value of the attributes. The syntax left side x1, x2 till xn. So such that the right side prediction of x1, x2 till xn. So in the left side x1, x2, x3, x4 are the domain variable used to get the column value required. The right side prediction of x1, x2, x3 is the predicate expression or condition. Just example, the student table. The student table consists of columns, for example, roll number, name, and department. Just look the question. Find all the data of the student who belongs to CS department. Then how to write DRC query? So what do you want to display? So you can mention in the left side, for example, R, that is the roll number, name, that is N, department, that is D. Now you are going to display. That is you have to write in the left side. The right side, this all the column belongs to which relation? That is R, N, D, that is belongs to student relation and followed by condition. For example, the department variable D equals CSE. Then automatically it will filter, then display the values. The DRC uses extensional and universal quantifier to bind the variable. We'll discuss one by one in detail. The existent quantifier, that is there exists. It is used to express that some values exist in the database for which the certain condition hold true. Just look the table, student table. So here three column, roll number, name and department. So what is the question here? Find the name of the student who belongs to IT department. Then how to write DRC query? So now you are going to display only name, right? So on the left side, mention the variable, that is the domain variable N. The right side, that is R, D, that is R means roll number and D means department. It is associated with the existing quantifier. Then followed by what are the variable, for example, column, roll number, name, department. This all are belongs to student relation. Then followed by condition, the department equal IT. So based on the way it will filter, then display. The result is Kumar and Lada. And next one is universal quantifier. It means for all. It is used to express the condition that must be true for every possible value. Just assume that there are three tables. Student table consists of roll number and name. Enroll table that consists of roll number and course ID. Then course table consists of course ID. So just look the question, find name of the student who are enrolled in all the courses. All the courses mean you have to select the universal quantifier. Then how to write DRC query? Now you are going to display only name. So just start with name, the left side. Then followed by the roll number is associated with exist quantifier. So roll number and name, this belongs to student relation. And the CID associated with universal quantifier. So again the CID is belongs to course. Implies the X variable, that is the course ID, that is associated with their exist quantifier. So the roll number and X is belongs to enroll and X equals CID. So now automatically it will filter, then it will show the result. For example, Arun and Kumar and so these are the students are enrolled in all the courses. A DRC formula is built up out of atoms. The relational atom, that is the domain membership. It means the domain variable belongs to the relation. For example, the left side x1, x2, till xn, this belongs to the relation R. And next one is comparison atom. It means the compare domain variable using comparison operator. For example, less than or equal, greater than or equal or not equal. The syntax is x that is comparison operator y. That is x means for domain variable and y also domain variable. So now we are going to compare using comparison operator, or the variable compare with constant using the comparison operator. The atom is the formula. If P1 is a formula, then the negation of P1 and P1. If P1 and P2 are formulae, then so are P1 or P2, P1 and P2, and P1 implies P2. If P1 of X is a formula in X, where X is the free domain variable, then the X is associated with exist quantifier, the quadratic condition is true, and the X is associated with universal quantifier, and the P1 condition is true. So, for example, A, comma B, comma C is associated with exist, then P of A, comma B, comma C, that is A, B, C, that is the condition is true. For there exists A and there exists B, then exists C, then P of A, comma B, comma C. I hope that you understood this concept. The next session we will discuss relational algebra. And the next one is the difference between relational algebra and relational calculus. There are different parameters we'll take. For example, relational algebra, relational calculus. Type. The relational algebra, it is a Purcell query language. The relational calculus, non-Purcell query language. The next aspect, how it will work. The relational algebra specify how to obtain the result, but relational calculus specify what the result is required. And next parameter, focus. The relational algebra, sequence of operation to get the output. The relational calculus, description of required result. And next parameter, operation used. Relational algebra uses like select, project, etc. But in relational calculus, use logical prediction with tuple or domain variable. The next parameter, easy of understanding. The relational algebra more difficult for beginner, but in relational calculus more user friendly and declarative. The next parameter, types. In relational algebra, only one type. In relational calculus, two types, tuple relational calculus and domain relational calculus. Next parameter, output. The relational algebra return a new relation as a result. In relational calculus, return the set of tuples that satisfy the given condition. So, in the next session, clearly we'll discuss about the relational algebra in detail. Thank you.